Okay, so we have a couple more examples here with exponential equations, and we use different concepts for both of them. So look at this first one. 3 to the x plus 1 equals negative 2. Well, obviously the bases aren't the same, and they're not going to be the same. You're not going to be able to get them to be the same. But we have a problem. This side, is that ever going to be a negative number? Because you can put in numbers all day for x, but you're not going to get a negative output. And over here we have a negative output, so these aren't going to be equal. There's no solution here. Now graphically, what does this function look like? Well, it's an exponential function, right? So it's going to go, and it's shifted 1 unit to the left. So it's going to do something like this. Not a very good picture, but something like that. And the asymptote, I was trying to get that asymptote in a different color. That asymptote is right there at the y equals 0 line. Well, where is negative 2? Negative 2 is way down here, and that's not going to ever cross our graph, right? So there's no solution here. Okay. I mean, you could draw a horizontal line at negative 2, but that's not going to intersect the 3 to the x plus 1 curve. Okay, so that's that idea. Now we have another one here where we have an exponential equation. We've got a base of 5 to the x plus 2 equaling the base of 4 to the x. Well, you're not going to get that 5 to look like a 4, and you're not going to get the 4 to look like a 5. 5 is prime, and 4 only breaks into 2 times 2. So we need a new idea, and that's where the logarithms come in. So probably need a little more room here. What we're going to do is we're allowed to take the log of both sides. Remember when we've had equations in the past, like we had x squared equals 9, and we said, oh, you can take the square root of both sides. And we had to put the plus or minus in. But what we were doing, we were applying the square root function to both sides. We did other things like when we had, the cubed root of x equals 3, and we said, we'll cube both sides. Again, we were applying a function. We're cubing both sides. Well, what we're going to do is we're going to take the logarithm of both sides. Now, you could use common log or natural log. I'm just going to use natural log. So we're going to take the natural log of 5 to the x plus 2 equals the natural log of 4 to the x. Okay, now remember the goal is to solve for x. So we have an exponent. We're going to use the power property to bring that x plus 2 down. When I do that, I'm going to need parentheses. X plus 2 times the natural log of 5 equals, and then I'm going to do the same thing over here, x natural log of 4, x times the natural log of 4. Okay, now just a word here. The natural log of 5, that is just a number. Put it in your calculator, it'll spit out a decimal. Natural log of 4, that is just a number. We're not writing it in front of the x because that gets really messy. So we're putting it behind it, but it's like the coefficient. It's just a number, okay? It's not a variable. That's what you have to remember. Our goal here is to solve for x. Well, we have x in 2 different places. Okay, so we're going to have to do some rearranging. First of all, we're going to have to distribute this number, natural log of 5, into the parentheses. So we're going to have x natural log 5 plus 2 natural log 5 equals x natural log 4. I have parentheses. I'm taking the parentheses off the 4. Okay, so what do we want to do? Well, we want to get x on the same side, and then the 2 natural log 5 on the other side. Now, we could do it both ways. We could either put the x on the left or the x on the right. I'm going to put it on the left. I might prefer to have it on the right, but we'll see what happens. And then this needs to go to the right-hand side. And then it'll become negative. So we have this statement. So this came over here, and now I have x natural log 5 minus x natural log 4, and it's equaling negative 2 natural log 5. Okay. We want to factor out on the left, we want to factor out the x. Okay, this allows us to solve for x. we're just going to divide both sides by natural log 5 minus natural log 4. That is just a number. You could put this in your calculator and it would spit out a decimal. But we're going to simplify it just a little bit here. So we know we can combine those two because it's subtraction. So we're going to write the denominator as the natural log of 5 over 4. And then in the numerator, this we're going to kick back up to its exponent spot and write the natural log of 5 to the negative 2. Well, we don't really want that negative 2 as an exponent, so we're going to change that and write natural log of 1 over 5 squared. And this is going to be the natural log of 5 over 4. And then just one more thing, the natural log of 1 over 25, and this is over the natural log 5 over 4. Now, you could change both of those to decimals. You could put that in the calculator. The book leaves it this way. I'm just going to leave it this way. Sometimes we just leave it this way. You can put that in a calculator, but it's a little more friendly probably to leave it this way. You can put that in the calculator and get a decimal approximation. We're not going to because we want an exact answer. So this would be considered an exact answer and not an approximation. Okay.